So a couple of things on number 8, if you were missing work, you did not get credit. You do not know how to multiply a binomial times a trinomial without any work. Agreed or disagreed? Because you have to sit here and double distribute or use a box. Remember doing that? So I was going to give y'all, your next review was going to have quadratics and probability on it. I think I'm about to give you more of this stuff because it looks like y'all need it. You're going to see a lot of this again in Math 3. So I hope you know how to multiply polynomials. I should have seen some work for this. Okay, so number 9 is tricky. I'm going to put some people on the spot, though, in a good way. I think Keyshawn, L'Oreal, Haley, Carter, I think Jay, maybe not, I don't know. There were like 10 of y'all that figured number 9 out just by guessing and checking. Sean did too. If you are building a pool and we have 36 meters of piping to go around the pool, 36 would be the what? Perimeter. Very good. Does everybody agree 36 is the perimeter? I want you to find what the biggest area of the pool could be. So what all of them did, because not a single person did it the way I did it, and I'm going to show you the way I did it in case that makes better sense to you. But what all of the people that did it right did, they just guessed and checked numbers. So when you're making a pool, it says it's rectangular, so that means the lengths have to be the same, and so do the widths. So what numbers did y'all guess and check first to find the area? What'd you try first? Okay, so I did 12 and 12, which is 24, which means there's 12 left. So then I did 6 and 6. That makes 36 for a perimeter, right? Okay, what would the area be of this pool? 72. So we're trying to find the maximum area. I need to see if I can find something bigger. So what Haley just said, you tried 16 and 16, and then 2 and 2. What's 16 times 2? Okay, so that's a smaller pool, right? So what did the answer end up being? Yeah, all 9s. So listen, when you think about a swimming pool, the overall biggest area for you to swim around the pool would be what shape? A square. Because the longer a pool gets, yes, it's longer this way, but its whole area is going to get smaller because you could almost reach over and touch the other side. Does that make sense? So if we're talking about the greatest area, it should be a square. Now, if you didn't know that and you kept guessing and checking, y'all look. We could try 10 and 10. So that would be 20, which means there's 16 missing, right? And 8 and 8. What's 10 times 8? 8. Okay, so we're getting bigger. That's good. What about 9 and 9? Let's try it. So if you did 9 all the way around, what is 9 times 9? 81. Y'all, that's the maximum area of the pool. Guessing and checking like this, that's a middle school concept. Did y'all not have middle school teachers that taught you like how to guess and check? A square is a rectangle. Yes. Right. No, a square is a rectangle. A rectangle is not a square. A rectangle, all 4 sides are not the same, so it cannot be qualified as a square. A square is a rectangle, and I did see a lot of y'all write that, which is good, but if you don't know the purpose of that for this problem, that's not going to help you. The whole reason why that works, why a square works, is because it has the maximum area. Guessing and checking, like your honors kids, you should be given a word problem, and if anything, be like, dang, I don't know. Let me start plugging some numbers in. Like, that's number sense. That's not really something I can teach you. Because a lot of y'all, let me show you what you did on this problem. That is so annoying. So annoying. Like, look at my face. I'm so annoyed by that. That tells me, dang, it's a word problem. I'm not even going to try because I'm lazy. Try it. Like, try it. Your exams, especially in Math 3, I hope you're listening because this is the whole reason why I'm doing this. When you get a Math 3 and take that exam, almost half of it is word problems. They're not hard. Like, I guarantee you there will be something like this on your Math 3 EOC next year. But you have to try it. You can't just look at it and be like, nah, I'm not going to do it. Because if you put a question mark, I counted it as incorrect. Like, you didn't even try. And I counted points off because you didn't show any work either. Like, a question mark is not work. Do we understand? Quit giving up. Don't be lazy and don't be giver-uppers. I don't like either of those. Okay? All right. I've taught you better than that. You should be able to plug numbers in. Now, for this one, I did not guess and check because I'm a math teacher, and in my brain, I automatically was like, I'm going to write a formula because it said maximum right here. What kind of graphs did we deal with in Math 2 that had maximums? Parabolas, which go with what kind of functions? Quadratic functions. I set up a quadratic function, graphed it in Desmos, found the max, and the max was 81. Does anybody want me to show them that, or is that gonna like stress you out? I can show you. It's not a can, because yes, I can. Do you want me to show you, or are you fine with guessing and checking? You want me to show you? Okay. All right. If you have a rectangle and the perimeter is 36, let me ask y'all a question. What is our formula for finding perimeter? How do you find the perimeter of a rectangle? Add all the sides. Good. So how many lengths are there? 2. How many widths are there? So perimeter is just 2 lengths plus 2 widths equals 36, right? Okay. Do you think we can solve for L's and W's at the same time? No. So what I did was I got L by itself, okay? So I moved 2W over, and the whole reason why I'm doing this, I need you to understand, you can't solve for 2 different variables at the same time. Doesn't work. So I moved the 2W over, so that would be 2L equals 36 minus 2W. How would you get L by itself? Divide everything by 2. So I'm going to come right here because I'm running out of room. So L just equals, what's 36 divided by 2? 18. Ooh, that was scary. What's 2 divided by 2? 1. So the length is just going to be 18 minus the width. I know that seems weird. Just go with me on it. If we make the length 18 minus W, and we make the width just W because I didn't solve for the width, how would you find this area? Can you say that again? Multiply. How do you find the area of a rectangle? Multiply. Some of you, this is going over your head because you're automatically giving up on it, and I can see it on your face. So I'm going to pause. I'm going to go back and make sure we're okay with this because you will have to do problems like this in Honors Math 3, like where you have to set up a function. Perimeter is 2 lengths plus 2 widths. Y'all told me I couldn't solve for both of them at the same time, so I just picked one. Do you think it matters which one you do? No, because we're going to multiply regardless, and when you're multiplying, the order does not matter. Is everybody okay? Okay, if you multiply W, I'll put it right here, times 18 minus W, do y'all agree that is just 18W minus W squared? Yes? Okay, think about that like x squared. That means that's a quadratic. Guess what? If you go graph this in Desmos, what do you think the max is? 81. 81. 9 is the length, but the maximum area that it would reach is 81. So that's another way you could have done number 9. Now, I know a lot of you are probably like, I would have never thought of that. You learned to do that in Math 3. But this was on the Math 2 exam because, again, you should have been able to guess and check. All right, number 10, that is something I taught you. And if you missed it, again, I was a little sad. I had pouty face when I was grading these this morning. It was sad, Macy. Macy's like, dang, Miss Poole. It says the base of a triangle is 4 square root of 6 if the area is irrational. So pause. What kind of shape are we talking about? A triangle. How do you find area of a triangle?
Very good. Base times height divided by 2. I'm going to make fun of some of y'all really quick. Why are none of us writing this when almost all of you got below a 60? We should be writing these. I'm not doing this for me or the people who got good grades. This ain't for them. They know what they're doing. Okay, I told you the base is 4 square root of 6, right? And then I'm asking you, if you keep reading, it says, which could be the measure of the height? All you had to do was plug the answer choices in and see which one gave you an area that was irrational. What does irrational mean? It goes on forever, yeah. Is everybody good with that? So I'm not going to do all of them. I'm going to show you what happened if you plugged in A. If you did 4 square root of 6 times 5 square root of 6, I'm not even going to worry about the dividing by 2. What's 4 times 5? 20. What is 6 times 6? Is the square root of 36 irrational? Why not? It's a whole number, it's 6, so it can't be A. If you did the same thing for B, you ended up with the square root of 144, and that's a perfect square, that's 12. If you plugged in C, that was the only one that was the square root of a non-perfect square. So that's the only one that could even be irrational. Are we okay with that? Okay, how did y'all do 11? What was the fastest, easiest way to do 11? Plug it into Desmos. So some people plugged the answer choices in and figured out maybe which one equaled 0. Because remember, when it says solution, you're finding an x-intercept. So the y value should be 0. Or I just graphed it in Desmos and clicked where it crossed the x-axis, because that's what a solution is, right? So you should have gotten A. That one should have been pretty easy. Number 12, so many of y'all were on the right track. Like, I was so excited. I was like, oh my God, yes. And then you just didn't read. I was like, dag on, like, read. If this was the exam, most of y'all would have gotten a level 1, which makes me sad, because I know I taught you better than that. What's rational mean? What's the first 5 letters in it spell? Ratio. Doesn't say anything about radicals. Think all the way back to January. I know it was a while ago. If I'm asking for rational form, I shouldn't see any radicals. So a lot of y'all simplified this and y'all said, okay, cubed root, if I have 6 x's, that means I can pull 2 groups out, right? So a lot of y'all said x squared and then y, which is correct, because if you have 3 y's and you need a group of 3 to take them out, that's one group, right? And then a bunch of you here said x, and then y'all said square root of y. That's not rational form. That's not a ratio. So the way I did it, I did good dog or bad dog. So with the y's, which dog was good, the 2 or the 4? The 2, and the 4 was your dog that slept outside, so he was bad. What's 2/4 reduced to? A half. So this is just x squared y times xy to the 1/2. And then when you are multiplying, what do you do with your exponents? Add them. So what's 2 plus 1 for the x's? 3. And how many y's did you have left when you added them? 1.5. So you could have put 1.5. That's a ratio. What else could you have put in? 3/2 would be 1.5. Can't put a mixed number. Those of you that had it square root of y, that also wasn't fully simplified. So like, I can't give you credit for that. Looks like y'all might have used some other resource. Does that make sense? Kind of? Okay, we're gonna stop there for today. The video is not over, y'all. We still gotta do notes. But I'm being hard on y'all about this because if we weren't in a pandemic, you would have an exam. These are old exam questions. Like, I need y'all are honors kids, so I am being hard on you. I know this year has been hard for everybody. It's been hard on teachers as well, like everybody. It's been a hard year.
but y'all are the kids we're relying on next year to come back to school and be ready to go. Like, okay? All right, so enough of that. We're gonna go over the test, start going over the test tomorrow. I know y'all saw somebody just left when I said not to. Is all about trigonometry. It's not bad. And transformations. So I'm gonna keep it real with y'all. If you say the word trigonometry to your parents, over half of them would probably have like a mini seizure. Because when they were in school, they learned trig not a good way. It was very difficult and like left a lot of them scarred, okay? The way we teach trig now, we use Desmos. It's not bad. And there's like a little mnemonic device that helps you remember what order the things go in, okay? So it's not bad. But this whole unit is about trig and transformation. So what we're doing today on page 44 is Pythagorean theorem review. Theorem review. So I'm gonna pause and let y'all get your notebook caught up. Your notebook check is coming up in 2 weeks. Very good. Okay, I'm hearing like lots of good things. They said in class a squared plus b squared equals c squared. You also should have learned something really like special too. So let's write that down first. The formula is a squared plus b squared equals c squared. Absolutely agree. I think almost all of you have seen that before. What kind of triangles does this work for? Right triangles, and that is it. So what we're doing the first half of this unit, all this trigonometry stuff, only works for right triangles. Does everybody understand that? Yeah? Okay, so if we have a right triangle, I want everybody to draw this. Draw a little right triangle. Which side is the C side? Okay, the diagonal one across from the right angle is what I heard. What's that called? Very good, extra credit. Hypotenuse. I have a little hippo up here. Let me show you. This is actually one of my better drawings, which is why I have it hanging up. It's a pretty good drawing. That's a pretty good hippo. Minus he doesn't have eyeballs. It's pretty good. Listen, that's good for me. Okay. The hypotenuse is like the diagonal part. So my teacher used to call it a hippopotenuse. I don't know why, but it like helped us remember it's the diagonal piece. Okay. So the hypotenuse is this diagonal piece. That's the C. It is called hypotenuse. I need you to call it hypotenuse because if you go into math 3 talking about some diagonal, they're going to be like, what? What's the hypotenuse? Which means A and B are the what? What do we call those? Technically, you could call them base and height. There's an even more just basic word. Oh, I'm so sad. It's okay though. Even more basic, you can't say sides because technically C is a side as well. Those are called legs. So when you do Pythagorean theorem, it is leg squared plus leg squared equals the hypotenuse squared. So this is the formula we can use when we're looking for different sides in a triangle. Is everybody okay with that? We learned that in middle school, right? Yes? Okay, so let's practice, and then I'm going to show you one thing you probably did not learn in middle school. So example 1, we're going to find the missing link in this triangle. All right, y'all, so this part's really important. This is where you will mess up. I am not looking for C. Does everybody agree? everybody with me? You already know C. C is what? 10. So when we're using Pythagorean theorem, that will help us find a missing side in a right triangle. Be careful. A squared plus B squared equals C squared. So the answer is not going to be 6. Are y'all okay if I put 4 in for A? Because that's a leg, right? Okay, so this would be 4 squared. Do we know the other leg? So let's call this B equals, what's C? So that would be 10 squared, right? Okay, what's 4 squared? Very good. 16 plus B squared equals, what's 10 squared? 100. So we're solving for B. What do you need to move to get B by itself? Yeah, you would subtract the 16. Good. So what's 100 minus 16 if we subtract that over? 80, what'd you say? 84. So B squared equals 84. How do you find what B is? Square root. Very good. So B equals the square root of 84. Which is what? L'Oreal looks so sad. Actually, I don't know if y'all are sad because I don't know if y'all are even thinking about what I'm thinking about. Is 84 a perfect square? In math 3, you will not be able to put a decimal, and you will not be able to just put square root of 84. Because there's a perfect square that goes into 84, which means you can do what with this radical? Simplify it all the way back to unit 1. I love math too. It all ties together at the end and it's fantastic. What number do we know if that goes into 84? That's a perfect square. Think about 8 and think about 4. What number goes into both of those? Say that again. 4. Dr. O'Day is so loud. All right, 4. Doesn't 4 go into 8? Doesn't 4 go into 4? Which means 4 should go into 84. 84, y'all, is just 4 times 21. 21 is not a perfect square. And I'm sad that we're having to do this all over again because I thought y'all would be okay with this, but it's okay. We're going to get it after this one. 21, the only factors are 7 and 3, right? Those aren't perfect squares either. So is this going to break down any farther? No. So this breaks down, Jake, you with me? And the square root of 4 and square root of 21. What is the square root of 4? 2. So do y'all agree B would be 2 square root of 21? Do we remember doing that in unit 1? That's how you're going to have to put your answers in Delta Math tomorrow. Not today. You just have a worksheet today. People at home, do y'all remember how to simplify radicals? Kind of.
Yeah.
Yes. Okay, good. Can I give y'all one to try? And then I'll show you the one new thing. And then we'll be done. Okay. Y'all try this one. So example 2, same directions. I want you to find the missing length of this triangle. So draw the triangle. I'm gonna pause while y'all do this one. Don't go anywhere though, because we got something new to learn / look at. So find the missing length for this triangle using Pythagorean theorem. All right, Pythagorean theorem. They gave you the 2 legs. What are you looking for this time? The hypotenuse, the hippo. We're looking for C, right? What is 10 squared? 100. What is 15 squared? 225. If you add those together, they should equal C squared. So C squared should have been 325, right? Which means, how do you get just C? Square root it. Henry, you sounded so excited. He's like, I really am, Miss Poole. I love math. The square root of 325. Now, that is not a perfect square. I'll help you out there. Think about money, y'all. If any kind of number ends in 0.25, like think about money, that would be a quarter, right? That means 25 should go into this. 25 does go into it how many times? 13. So y'all look, the reason I wanted to figure that out, what's the square root of 25? Just 5. So what should the answer be? 5 square root of 13. That would be your C value. Don't go anywhere because I'm not done. Yes, I can move it up. Sorry. Got to jump over my cord. Here you go. Do we feel like on our homework we can find missing links? There's 6 of those. 6 where you're just finding the missing links. Are we okay? Yeah? Perfect. Okay. So the only other thing I'm going to show you, and then I may be nice and do one of the word problems off the homework with you if you're good. L'Oreal's like, yes, please. Only other thing I'm going to show you, if I give you 3 lengths of a triangle, you should be able to tell me what kind of triangle it is. So let me show you what I'm talking about. I'm going to start off with just an example. Yes, write it down. Definitely write it down and follow along with me. And some of you may have seen this, but I know you haven't done the second part. I'm going to show you. So if I give you these 3 lengths and I want you to tell me what kind of triangle it is, how could you do that? What do you think? Any ideas? All right, let's stop and let's name our types of triangles. What kind of triangles can we have? Right. Okay, right has to deal with the angle. So let's talk about angles first. If it's not a right angle, then it's either, or a right triangle, it's obtuse or acute, right? By the sides, you should be able to look at this and tell me what Kedrian said is scalene, because none of the sides are the same, correct? Okay, so that's not what I'm talking about. Obviously, scalene. If 2 of them were equal, isosceles, all 3 were equal, equilateral, bada bing, bada boom. I'm talking about classifying it by the angles. So what did we just do on the front that had a formula that could tell us if it's a right triangle? What did we just do? Pythagorean theorem, which is a squared plus b squared equals. So you can use that to see if a triangle is a right triangle. I feel like we should have seen that in middle school or math 1 somewhere. So if I plug these into the formula, a squared plus b squared equals c squared, let's see if that's a true statement. Is 5 squared plus 3 squared equal to 49? No, this would be 25 plus 9, and we're trying to see if that equals 49. It doesn't, because what is 25 plus 9? 34. So this is the part I need y'all to understand. It's not a right triangle, is it? Very obviously, right? So if it's not a right triangle, well, do you know? I'm just writing this question down. You don't have to write this down. I want us to talk about it. Sean, pick your head up, babe, so we can talk about it. Because this is the part that will get y'all. It's not right. So how do you know if it is acute or obtuse? Exactly. Stop. I want you to say that again, but you're all backwards. So you look at 34 and you say, oh, it's smaller than 49, so it has to be acute. Listen, everybody watch. Let's think about a triangle. I'm going to draw y'all a picture so you can see, and hopefully you'll think of this picture when you get problems like this. If it is a right triangle, is everybody looking?
then that means this C piece will equal the two legs, aka it will connect them, right? So everybody see that? If C is bigger than the two legs, which is what we just got, everybody look, 49, the C squared was bigger than the two legs. So if C is bigger than the two legs, what that means, Jaden, C is bigger, it keeps going. What is this leg gonna have to end up doing? Opening out. So what kind of triangle would that be when they eventually connect? Because they will. Obtuse. If C is bigger, that means the angle is bigger. That's obtuse. If C is smaller, here's your right triangle. Then I just made C smaller. So what does this piece have to do to go in to meet it? It swings in and becomes acute. Does that make sense? So look at the one we just did. If I give you 3 side lengths, you should be able to tell me what kind of triangle that is based on the angles. So this is an obtuse. Obtuse what? Scalene triangle. Very good. It is not right. I feel like some of you probably need me to write down that little rule really quick. Yes? Okay, let's write it down, and then I'm going to give y'all like 2 to try. Does that sound good? Sure. Of course, Miss Poole, always sounds good. Okay, so like write this down. If a squared plus b squared equals c squared, then we know it's a right triangle, right? Yes? Okay. Which one do y'all want to talk about first? When it was smaller than C or bigger than C? Okay. So if C is bigger, if the 2 sides added are smaller and we make the C piece bigger, everybody look, we're making the C piece longer. That means it's going to have what kind of angle? Obtuse. Very good, Jaden. If C is bigger, that means it's an obtuse triangle. If we make the C piece smaller, then the sides are going to swing in and it's going to make what kind of angles? Acute. A squared plus b squared. If they are bigger than C, which means C would be smaller, that would be an acute triangle. Can I give y'all 2 to try? Yeah? Okay. You guys try these 2, and then I'll stop the recording, but I highly recommend everybody stay on because I'll do a word problem with you. How's that sound? All right, I want you to see what kind of triangles these 2 make. So for example, 4, I've got A equals 12, B equals 9, C equals 15. And for example, 5, A equals 2, B equals 6, C equals 7. So I just want you to use Pythagorean theorem. Tell me what kind of triangles these 3 side lengths would make for each one. I'm going to pause while y'all work it out. For number 4, when y'all plugged those lengths into Pythagorean theorem, did y'all get, let's see, 12 squared plus 9 squared? We're seeing if that equals 15 squared. 12 squared is 144. 9 squared is 81. Does that equal 225? Yes. So what kind of triangle was number 4? A right triangle. Very good. And it's a right scaling because none of those side lengths are the same. Very good. Any questions on number 4? What's wrong, Jordan? Did you you see it? Okay. 12 squared plus 9 squared does equal 225. So that was a right triangle. Now for number 5, I got 4 plus 36, which is 40. Does 40 equal 49?
No, so listen, let's think about it without just having to stare up here. Because yes, you can use this on the test, but I want you to actually think about it. The C piece is bigger, which means it is longer. So what kind of angle are we going to have? Obtuse. Very good. So this would be an obtuse scaling triangle. Does that make sense? Yes, because if they do end up being a right triangle, then I don't want to tell you yes because they may not be. Maybe. A lot of times they are scaling. They won't be equilateral because all equilateral triangles are acute because all the sides have to be the same. Yep. But for it to be acute, when you add the two legs, they'll be bigger than the hypotenuse. Yep, that's a good question. All right, I'm going to end the recording. I highly recommend staying because I'm going to let y'all pick a word problem off the classwork for me to do, okay?